friends, today let's solve course schedule 2. There are a total of n courses you have to take, labeled from 0 to n-1. Some courses may have prerequisites. For example, to take course 0, you have to first take course 1, which is expressed as a pair 0, 1. I think this part is anti-intuitive, because for the time order, if we need to first take course 1, then take course 0, I think it should be 1, 0. But it stay like 0, 1. You should notice this part. Then, given the total number of courses and the list of prerequisite pairs, return the ordering of courses you should take to finish all courses. There may be multiple correct orders. You just need to return one of them. If it is impossible to finish all courses, return an empty array. See this example. If there are only 2 courses and this is their relation, that means if we want to take course 1, we need to first take course 0. So the possible order is 0, 1. This question is a typical topological sorting question. So I think it deserves solving. Let's see how to solve it. Actually, I already explained before there are actually 2 ways to solve topological question: depth first search and breadth first search. And I think breadth first search is more intuitive and is more simple to understand. So I will also use BFS in this solution. Well, we have courses ID from 0 to n-1, and we have many relations. I prefer to write them like AB, and that means B is A's prerequisite. So that means B has an outer edge points to A. This is a directed edge because A is dependent on B. In the BFS solution, we need 3 data structure. One is three data structure. One is list. We call it in degrees. We need to record each nodes in degrees, because first we need to pick some nodes to give a topological sorting, right? So those who have in degree 0 should be handled first, because they have no prerequisite. They do not depend on other nodes, so we can handle them first. And once we handle those only have in degree 0, we can decrement their neighbors in degree by 1, because we remove that in degree equal to 0 nodes. So for the rest part, their directed neighbor in degree nodes should be decreased by 1. That's the core idea. And then we also need to change this relation to graph. And this is a dictionary. Actually, it's a map. Why? Because actually it's the agency list. For a node, we record its directed neighbors node, which means that node is pointed by that node. So if the given edge is B points to A, then we can know that A is in B's list. So B will be a key and A will be in its neighbor list. And then we also need a Q to do the typical breadth first search. And we will use list. Append means to offer a node to the queue. Pop 0 means to pull a node from the queue. So the algorithm is we iterate all the pairs and update the integers and the graphs for every relation, we can update the integers and try to build a graph. And then just to do a typical breadth-first search, we put all nodes that integer equal to 0 to Q, and for all its direct neighbors, decrement its integer by 1. I made the typos. This should be integer. And if after incrementing its integer equal to 0, put that node into Q, and we keep do these things until this Q is empty. And for this, and when we pull node from the queue, we may put that node to a candidate result list. In the end, we just check whether the length of that candidate result equal to the total number of courses. If equals, then we get a possible order. Otherwise, we just return an empty list. Okay, so now let's write the code. Today I will use Python, so you can comment below to tell me whether you want to see a Python version or a Java version. Okay, so as I said before, we need integers. And we only have n courses, so we just use 0 times number of courses. This is the initialization. And we need a graph. This is the dictionary. And for every relation in the prerequisites, we get AB, which is relation 0, and relation 1. You should recall that AB, given a pair AB, that means B points to A. So in that case, integers of A should increment by 1. And we will check, we will first get the node list. First it's empty. We check whether B exists in the graph. If not in the graph, then we just append A to the node list, and then graph B will equal to node list. Else, if in the graph, then the node list should just be graph B. And then we append A, then graph B will equal to node list. Okay, we finish building the graph and get the integers information. Now we need a queue with a list. So we iterate all the I because they only has range of number courses. So if integers are equal to 0, then Q will append this I. We get a candidate result list. And while this Q, the length of this Q is greater than 0, we should pull something from the Q, pop 0. Okay, we append this curve to the result. And if this curve in the graph, we will decrement all its neighbors by 1, or integer by 1. If it's in graph, then we get its neighbors will equal to graph curve. And for all the neighbors, decrements neighbor decrement by 1. And if integers neighbor equal to 0, then we pull, which is append the neighbor to the queue. Okay, and in the end we'll check if the length of the result equal to the number of courses. We return result, otherwise return empty list. So finished. Oh, sorry, courses. Okay, thank you for watching. See you next time. Right. I think the runtime is varies a lot. I think basically these three are the same code. Anyway, actually I think it's the same. Okay, see you next time.